Hello everybody, welcome to our introduction to Unit 4. Today we are just talking about how do we name these triangles. I'm sure we all know what a triangle is, right? A shape with three sides, but there are certain kinds of triangles that we are going to want to pay special attention to here in geometry class. So, classifying triangles by angles. This is where we are not looking at necessarily the sides of the triangle to name it, but we're looking at what's going on with the angles. So, if we've got three acute angles going on in our triangle, like we do here, right? That's less than 90, that's less than 90, that's less than 90. Then we actually call the entire triangle an acute triangle. Notice, we've got to have all three angles acute. We'll see how that applies on the next one. Here, this triangle has one obtuse angle. So to call a triangle acute, it had to have three acute angles. But to be an obtuse triangle, it only has to have one obtuse angle. And that's what we're going to call it, the obtuse triangle. Notice, the obtuse triangle still has two acute angles on it, but one obtuse angle is enough for the entire triangle to be called obtuse. Next, we've got one right angle. When we've got one right angle on our triangle, that makes it a right triangle. And it's going to leave us with two other angles. Later on in the trig unit, we're going to learn how to kind of manage those angles and what special relationships arise when we have a right triangle. And then finally, when we have three congruent angles, then we call this an equiangular triangle. Equiangular. Might be a new word for us there. So we've got acute. When we have three acute angles, when only one of the angles is obtuse, we call it an obtuse triangle. We call it a right triangle when it has one right angle, and three congruent angles makes it equiangular. We can also classify it by its sides. So if it has three congruent sides, maybe we're more familiar with that one. That is an equilateral triangle. Two congruent sides would make it an isosceles triangle. The way I remember to spell isosceles is I always say it wrong in class. So in class you might hear me say isosceles. That reminds us that there's a C after the second S there. Isosceles triangle. Now, when we have no congruent sides, that is called a scalene triangle. Scalene. So equilateral when there are three congruent sides, isosceles when there are two congruent sides, and then no congruent sides would be scalene. We can also classify our triangles even if we don't have a picture. So if they've just given us the three coordinates of the triangle, we can still use these to classify it by its sides. The way we do that is we have to use the old handy-dandy distance formula. So remember, the distance is the long square root of x2 minus x1 squared plus y2 minus y1 squared. So I can plug all of those in. We'll do jk first. Jk will be the square root of 1 minus negative 7 squared. Right? This is my y2 minus my y1. And then we'll add, I guess I did the y's first. It doesn't really matter. Next we'll do the x's. Negative 9 minus negative 7 squared. So that's going to be 1 plus 7 squared is 8 squared. Negative 9 plus 7 is negative 2 squared. Now, be careful when you type this into your calculator. If you type without the parentheses, it's going to think you want to do 2 squared and then make it negative. But no, when we square a negative number, we get a positive. So you want to either just put this in the parentheses or just lose the negative and do 2 squared. So this will be the square root of 64 plus 4, which is the square root of 68. And I believe we can divide a 4 out of that. So if we do 68 over 4, we get 17. Oh. So 68, the square root is actually, that breaks down into 4 and 17. So it's actually 2 root 17. Okay. Next we have KL. KL will be, I guess we'll do the same thing. We'll do y's first and then the x's, just because we're used to that from the slope formula. So -1 minus 1 squared plus -1 minus -9 squared. So that'll be -2 squared plus 8 squared. And those numbers look a lot like what we just did, 8 squared plus -2 squared. So we know this is going to turn out to be 2 root 17. And finally, we've got JL. This is the last possible combination. So remember, your triangle only has 3 sides. So square root of JL, so -1 minus -7 squared plus -1 minus -7 squared. So if we do the addition on this, we're going to get 6 squared plus 6 squared, which is the square root of 36 plus 36 is 72. And then 72 will divide into 18. I do not believe, 72 does divide into, 18 will divide into 9. So if I do 72 divided by 36, yep. And we should have known that since we did 6 squared plus 6 squared. But 72 divides into 36 and 2, which means that this is 6 root 2. So, since we've got 2 sides that are the same length and one side that's a different length, that reminds us of our isosceles triangle from the beginning here. So that triangle is isosceles. So that, when we're confronted with the 3 coordinates, it's a lot of work. We got to do the distance formula 3 times to find the length of each side. But once we have those lengths, we can compare them and see which are the same, which are different, how many congruent sides we have. So 2 congruent sides makes it isosceles. If they were all the same number, it would be equilateral. And if they were all were not the same number, then it's scalene. Let's also classify some of these triangles both by their sides and by their angles. On this one, we have a right angle and we have 2 congruent sides. So that makes it an isosceles right triangle. I'm going to use the triangle symbol here. We've got 114 degrees on this one and no marked congruent sides. So we're going to assume that it's scalene and also obtuse. So a scalene obtuse triangle. Do a little better on that one. Okay. On number 11, we've got 3 congruent sides, 7, 7, and 7, and we've got 3 congruent angles, 60, 60, and 60. So that makes it an equilateral, equiangular triangle. All right. Number 12, we've got 3 angles that all appear to be acute, and we've got 3 sides that are all different. So this is a scalene acute triangle. And on 13, again, no sides that are marked congruent, so we'll assume that it's scalene, and we've got a right angle there. So that is a scalene right triangle. And on that last one, we've got 2 side lengths of size 5, so 2 congruent sides, and 1 angle that is greater than 90. So this is an obtuse. We'll say isosceles first. Isosceles. No E on that. Isosceles obtuse triangle. All right. So these are the notes, but there is something I want to show you on the little homework sheet you have. 1 through 8, those are like what we just did, where we're categorizing by both the angles and the sides. But then on number 9, this looks a little more involved. So what number 9 is talking about here, we're using this kind of complicated diagram to classify, again, we're doing like what's up here, but now we've got multiple triangles in the mix. So they use their triangle names. Each of these is a triangle name. When we name a triangle, we put the little, this is called a delta, capital delta, it's a Greek letter, and that just is like the meaning of triangle. It means that it's an actual shape, a triangle. It's like putting plane in front of 3 letters wouldn't mean that it's a plane. Putting this symbol in front of 3 letters means it's a shape, it's a triangle. So what we're doing is we're confronting this diagram, and they give us a little bit of info that we're going to work through, and we're going to decide what each triangle is talking about. So they've already marked some angles and some sides that are congruent on here, but they also give us some additional info. So first, they say that QN bisects PQR. So PQR is this angle right here. And if it gets bisected, then it's going to break up into 2 equal parts. So PQN is going to be congruent to NQR there. N is the midpoint of PR. So that means PN is going to be congruent to NR. I'm going to do those with 2 tick marks because we already have 1 tick mark pair. And from there, I think we are good to classify each triangle. So PQR, for instance, PQR, we're looking at the entire PQR. So it kind of works how you would name an angle. We're looking at this whole thing. And PQR has 2 sides that are congruent. But we also have, if we look here, one of these side lengths is 14. And then on this side, we've got a 7, and that's equal to this side, which is also going to be 7. So 7 plus 7 is also 14. So really, PQR has 3 congruent sides to make an equilateral triangle. And then we've got angle Q here. We've got 2 30-degree angles. Well, that makes 60 degrees. And then we have 60 degrees over here. Well, remember, a triangle has to add up to 180 degrees. So this angle over here also has to be 60 degrees. So 60 plus 60 plus 60, 180. And so this is going to be an equilateral, equiangular triangle. And just like that, you're going to categorize the rest of the triangles on here. So for instance, PRT is this triangle right here. Remember, we've got a side length of 14 for that side. So go through, see if you can recognize what kind of angles we're working with, if it's acute, obtuse, equiangular, and then see if we have any congruent sides going on. On number 10, this is where you're going to be using the distance formula. You're going to find the distance between D and E, the distance between E and F, and the distance between D and F. All right. Thank you so much, and I will see you next time. Goodbye.